Hey, honors kids. I am at a conference today, so hopefully you are watching these notes and taking some good notes about this. We are finding the maximum or minimum value over a feasible region. So we've graphed inequalities, and then we found that feasible region, right? And after that, we find the vertex or the vertices. It's like the corners of our feasible region. And again, all of this is with no context, which is kind of hard, but that's because we're prepping for the real deal linear programming where we get a nice word problem, and the word problem wants us to maximize profit. Who doesn't want to make money, right? So now we're going to use a max or a min function to find the max or a min. And again, it will make no sense because we really have no context. But so in each of these, I'm going to kind of give you these first couple examples. I'm going to give you the graphed inequalities with the feasible regions, and the vertexes are really easy to find on the picture. And then we're going to do this, what we call the objective function. And that's like this, where I find a maximum, or this one where I find a minimum. So the first step here would be to graph them. Done. Feasible region. Done. Find the vertices. So these are labeled A, B, C, and D. So you should label yours. And I'm going to label them in order here. 3, 8. Oops. And once we have these, I'm going to put them in my table here. It's kind of like a double T table. This was A. This was B, C, and D. And now all I'm doing is plugging them into this objective function, and I want to find the maximum in this case. So this should be a little bit of room here where you have some room to write. Let's see, 9 plus 16. And of course I'll probably make a mistake because that's what I do when I'm talking to you guys and trying to do math at the same time. But if I did okay, the max here would be this point here. Okay, so the maximum then would be this point. That gives us a maximum of 29 because 29 is the biggest. And if I were asking you to find the minimum, okay, and again, this should make no sense because there is no context to it. You would do the same type of thing here where you would plug them in. And I didn't do 7 minus 16. But I hope that you see that this is the smallest one, right? Here we go. So again, if I did it right, if I messed up my math, you can tell me. Okay, so just another example where we do the same thing. Label your vertices. And 10, 8. Okay, and then we're going to put them into our table. And then this has a new objective function, and you'll see like this capital P quite a bit, P for profit. So in this case, we're probably trying to maximize our profit. So 0 for this one, right? Next one would be 32, 16 times 2. So 6 times 0.5 plus 2 times 18 is going to be 36 plus 3, so 39. And then this would be 5 plus 16, so 21. So in this case, our maximum, it's probably profit, comes from here. Okay, make sure that you are pausing me if at any time you need to stop. I know I'm going through these quickly. And C is usually cost. So you'll see this capital C quite a bit. Okay, and if I plug this one, I get this negative 64. Let's see, 6 times 1.5 is 9, and 4 times 18, 72. So I get negative 63 here. And then 10 times 1.5 is 15 minus 32, negative 17. So this would be my minimum value here. Okay, so really, again, no context. Doesn't make sense because there's no context. That's okay because we're working our way up to it. Okay, again, still no context. That's okay. But now we're kind of putting it all together, the stuff that we've been talking about so far. So I'm going to highlight here. I want to use yellow. Highlight here. And do like this. Okay, so the first thing to do is going to be to graph this. So this system of equations, when I graph the purple one, I'm going to make my t table, and I get 3, I don't know why I wrote zeros up there, and I get 4. Okay, so I'm going to graph this one, 0, 3, 4, 0, and I'm going to do my best here. Oh, that one was okay. I wish I could grab it by that side and try again. Let's see. All right, so I'm gonna have to go with it. And then we would test a point, right? So is 0 plus 0 greater than or equal to 12? No, that's false. Okay, so I would shade on the opposite side of 0, 0, so that would be here. Okay. Green equation. Don't want to use the green highlighter, would like to use the green pen. I'm going to do the same thing and make a t table. Again, you should be pausing if you need a break here. 0, 5 and 10, 0. See how I do with this one. Part of the fun, oh, that was almost perfect, is seeing how close I can get, right? All right, and so then I would test 0, 0. So is 0 plus 0 less than or equal to 10? True. So now I do want my green highlighter. So I would shade this way. Okay, I'm already starting to see where they might overlap. Blue here is actually 2 equations. It's x greater than or equal to 0 and x less than or equal to 4. Okay, so there's 2 equations. So x greater than or equal to 0, that should be right on the 0, but we're going to pretend that it is. That should be right on the 4. And I would shade in between these two because we talked about compound inequalities at one point. And I can kind of now see where this shape is. Kind of looks like it's a quadrilateral. It's a 4-sided shape here. I can see my vertices. Okay, I'll color that in. This would be my feasible region. Okay, so we've graphed, we've shaded, we found the feasible region. Now I want to use my objective function. So I'm going to make that table just like above. So here would be my vertices, my objective function, and then my answer when I plug them into my objective function. And I'm asking you to maximize the value. Okay, so I took up a lot of space here, like usual. All of these are right on vertices. You could, and probably should, do the algebra for these. I'm going to skip it at this point just for the sake of time. But you could find this set of equations and be able to find all of these, especially since we color coded them, right? They should be pretty easy to find. So I'm going to list my vertices. And then I'm going to plug them in here to my objective function. So I get 0 minus 6, oops, 0 minus 10, 4 minus 6, and 4 minus 0. And so it looks to me like my maximum would be at this vertex here. Okay, so you need to take these notes, do the homework, and submit it. Remember, we have no Google Meet on Wednesday. I'll be at a conference. There'll be a quick quiz open for you on Wednesday to take. All right, that should be everything.